This is a quick video on how to identify equations that are in a quadratic form, so in the form of a quadratic trinomial. So if we look at these equations, we're going to talk about how each one can be factored similarly to a quadratic trinomial. So the first one we have x to the fourth plus 7x squared plus 10. So if we think about this like the equation x squared plus 7x plus 10 equals 0, we know that that is a trinomial with a leading coefficient of 1, and so all we have to do is find two numbers that multiply to 10 and add to 7, and that would be 5 and 2. So we know that this would factor to x plus 5 times x plus 2, and so if we're factoring something to the fourth power, we know that instead of x times x, we're going to get x squared plus 5 and x squared plus 2. So even though that's a fourth degree polynomial, we can factor it similar to a quadratic. The next one looks completely different. However, we can also factor this one like a quadratic trinomial. So if you think about, so we have e to the 2x minus e to the x minus 12. So I'm going to write the quadratic that it is similar to right below it. So if we think about factoring that, we would say what multiplies to negative 12 and what adds to our b value, our negative 1, and that would be x minus 4 and x plus 3. So when we have this exponential form with a base of e, this is going to factor to e to the x minus 4 times e to the x plus 3. And if we are solving that, if we're solving logs or exponential equations, we would set each of those factors equal to 0, and then we would solve using logarithms. So that's how we can turn that exponential function into a quadratic trinomial. So the last one, we have a trig equation. And so again, we can think of this as 2x squared minus x minus 1. And we're recognizing that quadratic trinomial, and this one does have a leading coefficient. So we can either directly factor it, or if we're stuck and not sure, we can make our area model. We can put our 2x squared and our negative 1, and we can say, okay, what multiplies to negative 2x squared and adds to our middle term of negative 1? And that would have to be 2, negative 2, and positive 1. So we're going to put negative 2x, positive 1x, and then we're finding the greatest common factor in each row and column. So that first column just has an x. The second column has a negative 1. The first row has a 2x, and the second row has a 1. So that means that this would factor to 2x plus 1 times x minus 1. So we did that factoring like a quadratic, but if we put the cosines back in, this would factor to 2 cosine of x plus 1 times cosine of x minus 1. Then again, we can set each of those factors equal to the 0 and solve and find the angles that correspond.